Good morning and once again welcome to my YouTube channel, Maths with Ease by Mr. Kamotho. And in this video we are facing example 5, whereby we are told to find a counter example to prove that 2n squared plus 29 is not always prime number. And this is a continuation of the explanation in the slide. We are told that 2n squared plus 29 will always produce a prime number up to and including when n is equals to 28. And by the time you get to when n is equals to 28, most of the students would have given up and the situation will have looked to be true. That when you substitute n with numbers between 1 and 28, you will always keep getting prime numbers, and by then most of us will have given up. So it is a continuation of what the slide is explaining. I hope you have understood what the slide is saying, and I just want to approach this question from the strength of the slide, whereby this statement will always give you prime numbers up to when n is equals to 28. So when the question is saying find a counter example to prove that this statement is not always prime, I would be wasting time if I use n is equals to 1, n is equals to 2, all the way to n is equals to 28. But I would want to start when n is equals to 29, borrowing from what is explained in the slide. So when n is equals to 29, then we have 29 squared plus 29. That is what we have. And if you look at this, I would want to find out what is this equals to, whereby this is 29 squared, that is equals to that, times 2 is equals to that, plus 29 is 1711, 1711. That is the product. To prove that this is not true when n is equals to 29, we can now arrest this part of the equation, and within it we can already see that 29 is common. So if we can have 29 common, inside the bracket we have 2 times 29, of course, plus 1, and close the major bracket, in the sense that this one is basically 2 times 29 times 29. This is what it means, 229 times 29 plus another 29. And this being just one term, and this being another term, this is what has been written in that particular format. And I can even write it again here, where this is one term, 2 times 29 times 29. Within this term, 29 is common. And inside the bracket, we have this 2 and this 29. 2 times 29. We can close that bracket because that is it. But within this one term, 29 is actually itself, which is now added there. And 29 divided by what is common, 29, is actually 1. Opening this bracket, we have 29 multiplied by 29 times 2, which is 58. 58 plus 1 is 59. And we can see, let's see what this one is all about. 29 times 59 is the same 1711. Is the same 1711. So now that 1711 can be given by 29 times 59. In other words, 1711 is not a prime number, because prime numbers are the numbers that are only divisible by 1 and themselves. And we have just found out that 1711, or rather 1711, is divisible by 1, yes. Is divisible by 29, yes. is also divisible by 59, yes, and it is divisible by itself, because you can already see 29 times 59 gives us 1711. So this one is not true. This one is not true, whereby 2n squared plus 29 always gives you prime number is not true. So the statement is not true, whereby 2n squared minus 2n squared plus 29 will not always give you a prime number, because we have proved it using that example. Thank you, and let us meet in the next video.